This is Module 6, Section 1.8, Simplifying Expressions. When simplifying expressions, you need to know how to combine what are called like terms. Like terms are defined as having the exact same variable factors in common, and all the variables have to be exactly the same. So, for example, if you had, let's say, x squared and 2x squared, those are considered like terms because the variable piece, which is the x squared term, are exactly the same. So those are indeed like terms. Another example might be 3y and, let's say, 24/25 y. Okay? Doesn't matter what the numerical coefficient is, it just matters whether the variable pieces match, and in those cases they do. Unlike terms, on the other hand, have different variable factors. So an example of two unlike terms might be 4x squared and 3x. Yes, they both have x's, but the x's are not exactly the same. One is x squared and one is x, so those are considered unlike terms. Another example might be a squared b and 3ab squared. Again, the variable piece, if it's not exactly the same, make those unlike terms. And then, of course, obviously, if the variables are completely different, like ab and 4xy, those are unlike terms because the variables are not alike at all in those cases. So, when adding or subtracting expressions, you need to have like terms. If you do not have like terms, you cannot combine the expressions. So, for addition and subtraction, you must have like terms in order to combine them. So the next question is, how do you subtract like terms? Okay, we're going to start with a review of the distributive property. Remember, with the distributive property, there was a factor out in front of a group. The group had either addition or subtraction in it. And what we did with the distributive property is we multiplied that factor out in front to each term in the group. So a times b was ab, a times c was ac, and then the operation carried along in the expanded form. Okay? Using different values, let's say you were doing this problem and you were asked to use the distributive property to write in expanded form. You would take that 3 and you'd multiply it to each term in the group. Remember, terms are separated by addition or subtraction. That would give you 3 times 2x plus 3 times y. And if you clean that up, this is all straight multiplication. 3 times 2 times x. 3 times 2 is 6. 6 times x is just 6x. Okay, plus 3 times y is 3y. Okay, so that's an example of distributive property. Remember, subtraction worked the same way. You'd multiply the a to the b and get ab. You'd multiply the a to the c and get ac. And then the subtraction just carried along if the original group had subtraction in it as well. All right. Now what we're going to do then is we are going to use the distributive property, but we're going to reverse it. Okay? So instead of taking a term times a group and expanding it out, we're actually going to go in reverse and take the expanded form and put in some grouping symbols. So for example, if you reverse the two above examples with distributive property, notice we're starting with the expanded form and we're putting the groups in. Now here's what you want to notice there. Notice that in order to go in reverse, we're looking at each of the terms in the expanded form and we're looking for a factor that's common. What is a factor that's common? In this first example, A is common. So if A is common, you can write it once, and then if you take those A's out of there, that gets multiplied to the group of what's left. And what's left, if you remove the A's and write it out front, is B plus C. In the second example, it's very similar. Okay, the common factor is A, so you write the A once, and then if you have removed those A's, what you're left with is the group B minus C, and that's right there. Factoring like that is not something we've talked about in detail. That's actually later in this module, but that's a basic rundown. So combining like terms deals with this distributive property in reverse, and so you could think about a problem like this, for example. Let's say you had 2x plus 8x, and you were asking yourself, okay, what's common in those? Is there some common factor that I could use the distributive property in reverse and pull something common out in front? Well, you agree with me that if I wanted to, I could write 8x as 2 times 2 times 2. 2 times 2 times 2 is 8. And the only reason I might write it like that is now I can see that I do have some things that are common. I have one of the 2's that's common, so I could write that once. And I have an x that's common, so I could write that once. And then I could multiply that to what's left. Well, what's left? What's left in your first term here, if you took everything out, is just an understood 1. And then if you take the 2 and the x out of this, you're left with 4. So that gives you here 2x times 5, and 5 times 2 is 10x's. All right, so let's do another example. So 2x plus 8x is 10x. Let's say you had 5ab minus 3ab. If you were using the distributive property in reverse, you agree with me that the a and the b are common, so we could write that once using distributive property in reverse. And if you take the a and the b out, what you're left with is 5 minus 3. 5 minus 3 is 2, and a times b times 2 is the same as if we write the numerical coefficient first, 2ab. Okay, let's look at another example then. Let's say that you were looking at this problem. 3x plus 45x plus x. Okay, you agree with me that this x right here looks like it doesn't have a numerical coefficient. It looks like it doesn't have a number in front of it, but we talked about that. If there's not a number in front of it, you can think about that as an understood 1, because 1 times anything is itself. 1 times 5 is 5. 1 times x is also x. So if you write down the thing that's common using the reverse of distributive property, there's an x that's common in all of those. You can then look at what's left, which is 3 plus 45 plus 1. 3 plus 45 is 48, plus another 1 is 49. So you've got x times 49. And usually we write the number first in a term. And so we'll put the 49 out front, and we've got 49x. Now you might notice as we do those that what we're really doing, if you look at the problem when you begin, is it turns out that when all of the terms are like terms, all we're really doing is adding or subtracting the numbers out in front, the coefficients, and then the x just carries along. Okay? So although the reverse distributive property mathematically is what you're doing, if you want a shortcut, and everybody does, okay, all you really need to do is, as long as the terms are the same or like terms, just look at the numbers out in front, do the mathematical operation to the numbers out front, and then add whatever variable is on at the end. Okay, and I'll give you an example. If you were doing, let's say, 5x plus 3x, before what we were doing is we were writing down the x and then multiplying that to the group of what was left, which is 5 plus 3. But the shortcut is look and see if they're like terms. And they are. They have to be like terms in order to add or subtract. Okay? If they're like terms, then all you need to do is simply do the math to the coefficients out front. 5 plus 3 is 8. And then whatever the like term is in each of the expressions, you're going to rewrite that like term again. And so this, in real life, would be like this. If x represented apples, you would agree with me that 5 apples plus 3 apples equals 8 apples. Notice that the x doesn't change, it's just the number. Apples plus apples is apples. It's not apples plus apples equals oranges. So when you're adding or subtracting like terms, the variable piece does not change, only the numbers out in front. So another example might be, let's say, how about 10xy minus 3xy. Again, you could do that reverse distributive property which we initially introduced, or you can just remember, if you have like terms, and we do because the variable piece is exactly the same. All you need to do is the math to the numbers in front, so 10 minus 3 is 7, and then the variable piece carries on unchanged. If it's xy in this term and xy in this term, then it's going to be xy in this term as well. And again, let's say xy represented apples in real life again. If you have 10 apples and you take away 3 apples, you're left with 7 apples. The apples piece does not change. The variable piece does not change. Okay, so the summary of that is, to simplify combining like terms, just add or subtract the coefficients and keep the same variables, just like we've been doing in the previous example. So let's do a few more. We'll just bring up all of our example boxes and do all 3 at once. Let's say I gave you 25y plus 12y. Okay, to add or subtract, you need like terms. Do you have like terms? Yes, you do, because the variable is exactly the same. So do the math to the coefficients out front. 25 plus 12. 25 plus 12 is 37. And then the variable piece just rewrites and carries on to it. So 25 apples plus 12 apples is 37 apples. 25y plus 12y is 37y. Here's another example. 8w squared minus w squared plus 6w squared. Okay, now that has 3 terms in it, not just 2, but it doesn't matter. If you have subtraction and addition, you must have like terms, which means the variable piece has to be exactly the same, and it is. With the second term, where it says minus w squared, there isn't a coefficient showing, but remember we said if a coefficient is not written, there is an understood 1 there, because 1 times anything is itself. So if you just look at the coefficients, the numbers out front, you've got 8 minus 1 plus 6. Working left to right, because orders of operation have subtraction and addition at the same level. 8 minus 1 is 7. 7 plus 6 is 13. So 13 what? If it's an addition or subtraction problem, the variables do not change it's 13w squared. Another example, let's say you're doing this problem. M minus 4m plus 2m minus 6. Now this problem is a little bit different because we have 4 terms, 1, 2, 3, 4, of which only 3 of them are like terms. The first 3 terms here are like terms, and the minus 6 is separate. So in this case, we're not going to be able to write it as a single term, but we'll add and or subtract what we can, combine like terms where possible. So we're going to look at this piece right now. Those are all like terms. They're all m to the first. So remember that first m has an understood 1 in front of it. Do the math out front. 1 minus 4 is negative 3. Negative 3 plus 2 is negative 1. Negative 1 what? Negative 1m, because that was the like term that we were combining. Now the minus 6 on the end is not a like term, and with subtraction you need like terms. So since m and minus 6 are not like terms, you cannot combine them, so you'll just have to rewrite it, and you'll have to leave your answer with 2 terms. Okay? This is your final answer for this problem. As always, with ones, you can drop the 1 if you want to. This is equivalent to minus m minus 6. Remember, the 1 is optional. If there's not a 1 written, it's understood. Okay, sometimes you need to distribute first before combining like terms. And let me give you some examples of that. Let's say that you're asked to simplify the following. 6 times the group, 4y plus 2 minus 7. Okay, your goal is going to be to combine and simplify all the like terms you can. But in order to combine like terms, you need to have all the terms free and not bound up in a group. So in this case, to simplify this problem, you are going to have to use the distributive property first in order to get rid of those parentheses. You've got to get rid of the parentheses. So let's do that. Here we get 6 times 4y, I'm distributing the 6, plus 6 times 2, and then that minus 7 is still there, even though I haven't done anything with it yet. Okay, now it's an orders of operation problem. You've got multiplication, you've got addition, and you've got subtraction. You always do multiplication first, working left to right. So 6 times 4 times y is 24y. Here we have another multiplication step. 6 times 2 is 12. And then the operation between those two is addition, as it was above it, and then minus 7. Okay, now at this point you have 3 terms. Of those 3 terms, your 3 terms are 24y, 12, and 7. Only 2 of them are exactly the same. Okay? The 12 and the 7 are like terms. They're both just numbers without a variable. So you can do that math. 12 minus 7 is 5, positive 5. That's being added to 24y from above. 24y plus 5, those are unlike terms. With addition, you have to have like terms to combine them, and so you are done. That is your final answer for that particular problem. Another example. Let's say that I asked you to simplify this problem. Let's do 7 times m minus 3 plus 10. And the instructions would say simplify or combine like terms. Again, in order to combine like terms, you have to get rid of the parentheses. So first we're going to distribute the 7. So we've got 7 times m minus 7 times 3, that's the distributive property, plus 10, which is tacked on to the end of that expression. Orders of operation, do the multiplication first. 7 times m is just 7m. I'm going to drop the parentheses just because it's less writing. Minus 7 times 3 is 21, plus 10. Combine any like terms that exist. We have like terms right there. Minus 21 plus 10 is minus 11. We still have the 7m, which is an unlike term. 7m and 11 are unlike terms. With subtraction, you need like terms to combine. That's your final answer. You want to watch out for negative signs or a subtraction operation before parentheses when you're simplifying these expressions. Negative signs or subtraction operations need to be distributed to the entire group. This is a very common mistake in math, so this is something that you really want to watch out for when you get problems like this. For example, let's say that you're asked to simplify 7 minus 8 times the quantity 2a plus 3. All right, now there's a couple of ways you can think about this problem. One way is recognize that any subtraction problem, and I'm going to do an easy subtraction problem off to the side. Any subtraction problem can be rewritten as an addition problem. In other words, you can change subtraction to addition by adding the opposite of what follows the subtraction sign. Now, the opposite of a number simply just means to change the sign. So here, we were subtracting a positive 3. If we add the opposite of positive 3, which is a negative 3, in both cases we get the same answer. Okay? And double check that. You agree with me that 5 minus 3 is positive 2, and 5 plus a negative 3 also is positive 2. So anytime you have a subtraction problem, it's the same as taking the addition of the opposite. So subtraction is the same as adding a negative. Okay? Either way, in this case, you would agree with me, you get a positive 2 as well there. So thinking about that with this problem, we could, if we wanted to, change that 7 minus 8 to a 7 plus negative 8. And if you agree with the examples that I did over here, then you should agree that it was okay that I did that there. I changed subtraction to adding a negative. The only reason I did that is because that makes it clearer that since this particular step is a distributive property step, you would distribute not a positive 8, but rather a negative 8 to each term in the group. So that would give you negative 8 times 2a plus negative 8 times 3 for the distributive property step. And then the number and operation out front would just rewrite because I haven't done anything with that yet. Okay, now at that point, okay, orders of operation, do the multiplication first. So we've got 7 plus negative 8 times 2 times a is negative 16a. And negative 8 times 3 is negative 24. And now, if we take that, and I'm going to bring it over here, if we combine like terms, okay, there's two constants here, so constants are like terms. We've got 7 plus negative 24 leaves you with a negative 17 plus negative 16a. And those two terms are unlike terms. You can't combine an a with a constant. That would be your final answer. Now, another way to think about that is this. If you looked at that problem again, So same problem. But you didn't want to go to the trouble of changing that subtraction to adding a negative. If you simply remember that if there is a subtraction sign in front of a parenthesis, you need to distribute not only the 8, but also the subtraction sign. And so at this point, if you wanted to, you could just remember, all right, I need to distribute both the subtraction and the 8, which is the same as distributing a negative 8. So you would get the 7 out in front, then you'd have minus 8 times 2a plus minus 8 times 3, which gives you 7. Minus 8 times 2 times a is negative 16a, or minus 16a. Remember, adding a negative is the same as subtracting. Here you've got plus negative 24. Combine like terms. As you did before, you still get negative 17 minus 16a. Same answer, just written a little bit differently. Remember, adding a negative is the same as subtracting from the previous slide. Let's look at another example. Let's say that I asked you to simplify this problem. 4 times the quantity x minus 3 minus the quantity 3x plus 4. Okay, like the problem above it, there's a couple of ways you can think about this. Since there's not a number written in front of the group, sometimes students aren't sure what they need to distribute. Remember that when in doubt, you can always put in a 1, because 1 times anything is itself. So if you wanted to do this problem like the problem right above it, you could take that subtraction and change that to plus a negative. Okay, so instead of subtracting 1 here, you can write that as plus a negative 1 times the group. Now it's a fairly straightforward distributive property problem. Okay. For the first group, we would take 4 times x minus 4 times 3 plus, okay, now we're going to distribute the negative 1. Negative 1 times 3x plus negative 1 times 4. Okay, let's clean that up. That gives us 4x minus 12 plus negative 1 times 3 is negative 3 x's plus negative 1 times 4 is negative 4. Combine like terms. Notice we have two groups. We have a positive 4x and a negative 3x. Those are like terms. So 4 plus negative 3, we bring it up here. 4 plus negative 3 is positive 1 x's. Remember, you just add or subtract the coefficients and rewrite the variable. And then we also have a minus 12 and a minus 4. Minus 12 plus minus 4 is minus 16, or plus a negative 16 if you like that better. Adding a negative is the same as subtracting. And if you want to clean that up one further step, you don't have to write that 1 unless you want to. 1 times x is just x, so we've got x minus 16. An alternative way to do that problem, if I rewrite this problem again, we've got 4 times x minus 3 minus, this is the way it originally was written, minus 3x plus 4. If you don't want to write the 1, okay, the first step is the same here. The 4 is straightforward. It's just going to multiply to each term in your group, distributive property. Here, if you don't want to write the 1, just recognize that that subtraction sign has to apply to each term in the group. Now, a subtraction sign is like taking the negative of something. If you take the negative of something, it changes the sign. So, just starting with this second group here, if you subtract 3x or change the sign of positive 3x, it becomes minus 3x. If you take minus a positive 4 or take the opposite of a plus 4, it becomes minus 4. It changes the sign or changes the operation. You're distributing the subtraction sign. Okay, in the first step, it's the same as what we did before. We've got 4 times x minus 4 times 3. Clean that up. 4x minus 12 minus 3x minus 4. Combine like terms. 4 minus 3 is 1x. Negative 12 and negative 4 is minus 16 or plus a negative 16. And just like before, if you want to drop the 1, you can, because 1 times anything is itself. We get the same answer we did before over here, x minus 16, just a different way to think about it. So that brings us to the end of Module 6, Section 1.8 material. You should now complete the homework for Section 1.8 found in MyMathLab. And when you have successfully completed that homework, you can proceed to the video for the next module, Module 6, Section 2.1, 2.2, and 2.3.